If I asked you what the biggest problem with a quadratic equation that has got complex roots is, you'd probably say, I don't care. If you asked a mathematician what the biggest problem with an equation with complex roots is, they'd probably give you an answer containing the word Euler. But if you ask someone, they will probably tell you that the biggest issue is you can't plot it on a graph. If you had a quadratic equation that had roots 1 plus 2i and 1 minus 2i, complex conjugates of one another, of course, and you were to plot this quadratic on a graph, well, it would go somewhere there maybe. It might be over here, I don't actually know what the quadratic is. But the point is, it wouldn't be intersecting my x-axis, right? At GCSE, at lower levels, this is how you would know that a quadratic is useless, can't be used, because if you plot it on a graph, it does not intersect the x-axis. Now we know that means that it's got complex roots. Shouldn't be discarded, should just be treated slightly differently. But what if, because, we like our graphs, you wanted to plot it? Or more specifically, you wanted to plot the roots. Well, luckily, we've invented something for that. Argand diagrams. Now, they're diagrams rather than graphs because we're not actually plotting, at least not right now, a shape. We're not plotting a set of points. All we're doing is we are plotting a way to visualize where our roots might be. So, what does an Argand diagram look like? Well, the lines look the same as a regular graph. We even have little arrows on them like that. But instead of having an x-axis and a y-axis, we have a real axis and an imaginary axes. Real going along the x, imaginary going along the y. And it's relatively simple to get your head around how to draw things on here. So going back to my 1 plus 2i and 1 minus 2i, okay, I need to relate these to my axes. So I know that my real axis is on the x. So these values here are essentially my x values. And I know that my imaginary values are on my y-axis. So these are essentially my y values. So we can say, to make things a little bit easier for us, that all of our complex numbers can be written in the form x plus or minus yi. Y being the imaginary value, x being the real value. And I can plot these on my graph exactly as I would an x and a y. So, my real values, let's just, for simplistic sake, say 2, 4, 6, 8, and then my y, the same thing. Minus 2, minus 4, minus 6, and so on. Just finish it all for posterity. That'll do. Horrible, but that'll do. And we can plot them as follows. My 1 plus 2i has a 1 on the real axis, the x-axis, there. And it has a 2 in the imaginary, in the y. So it would go here. Yeah. And that's all it is. It's a little point on my Argand diagram showing where this root is. 1 on the real, 2 on the imaginary. 1 on the real, minus 2 on the imaginary. And then it would look like that. Another example. 4 plus 6i. 4 on the real, 6 on the imaginary. If I wanted to conjugate that, 4 minus 6i would be down here. Now, the way that we label these, the way that we make sure we know what's going on the graph, is we very, very usually, and it's good practice to start doing this, draw an arrow, preferably a straight one, from the origin to the point with a ruler. And then label it, so I could just label that as Z2 and say that that is Z2, in which case that would be Z2 conjugated. Same way that could be Z1, and that could be Z1 conjugated. So this is how we label them. So it looks a little bit different to a normal coordinate axis, but in general, the principles are the same. We just need to remember that our x goes here and our y is here. X plus or minus yi. And that is how we plot an Argand diagram. Does it stay that easy? Probably not.